Hi, this is lesson 4.3, page 225, graphing using intercepts. This writing up here does a great job of explaining what we need to do to graph using intercepts today. So we're going to read through this first, and then we'll actually do it together in the video. You can use the fact that 2 points determine a line to graph a linear equation. 2 convenient points are the points where the graph crosses the axis. Now when they mean axis, they mean the y-axis, which I'm pointing to here, and the x-axis that I'm pointing to here. These points, which maybe I'll highlight them in blue here, these 2 points that I'm highlighting in blue would be nice points to use to draw my line. Those 2 points have a name. You've already learned it in lesson 4.1. This point here is the x-intercept. The x-intercept is where my graph crosses the x-axis. The y-intercept, that would be this point here. That's where the line crosses the y-axis. If we know those 2 points, we could plot them and draw a line through them, put arrows at the end, and we have a graph. Now to do that, to find the x-intercept, which is this one here, to find the x-intercept, all you need to do is plug in 0 for y in your equation and find x. So you notice that the x-intercept, y is 0. So if I plug in 0 for y, I'll find out how many units over on the x-axis my x-intercept is. And in the same fashion, to find the y-intercept, if you just plug in 0 for x, you would find y. Now, if those words are a little confusing, I'll show you an example right below here. Let's find the x-intercept and y-intercept of the graph of this equation. Now, do you notice a couple things here? This is in standard form. Let's review that. Standard form, remember, is ax plus by equals c. Can you see how this is in this form? I'm writing it down. My pen will work. Okay. Now, standard form is always linear. This would be a straight line graph. Now, okay, let's find the x-intercept. To find the x-intercept, I got to plug in 0 for y. So let's do that. I'll plug in a 0 here. What happens if I plug in a 0 here? 7 times 0 cancels out. You would get 2x on the left, 28 on the right. Divide by 2, you just found out the x-intercept is at 14. In other words, this is the point 14 for x, 0 for y, and I could go on graph paper and go 14 over and plot a point. Okay, let's do the same thing now to find the y-intercept. I have to plug in 0 for x to find the y-intercept. So I'll plug a 0 here, and 2 times 0 is nothing. So I have 7y equals 28, and if I divide by 7, I would get y equals, y equals 4, which means this is the point 0, 4. So if I wanted to graph this, I could take the point 0, 4 and plot it. That was my y-intercept, and I could take the point 14, 0, which was my x-intercept, and I could plot that, and then I could take my ruler out, and I could just draw a line between these points. Let me do that in a couple directions here, and put arrows at the end, and there would be a graph of that particular equation. So that's what they mean when they're talking here to find the x-intercept, plug in 0 for y and solve, and to find the y-intercept, plug in 0 for x and solve, and that's how we could graph this. So this is a convenient way to graph certain problems. Not all, I'll show you why in a little bit, but certain problems. Okay, let's go and try a few. Let's find the x and y-intercept of these particular standard form equations. So let's do this one first. Let's find the x-intercept. That means I got to plug a 0 in for y. So let me just write this down. I'm plugging in 0 for y. 2 times 0 is nothing. So 3x would equal 6. Divide by 3, x would equal 2. So I know 2, 0 would be the x-intercept. Let's get the y-intercept now. We have to plug in a 0 for x. So to do that, I'll put a 0 here. 3 times 0 is nothing, so I'd have 2y equals 6. I can divide by 2. Y would equal 3. There is my x-intercept and y-intercept for problem number 2. Okay? I'm sorry, problem number 1. Problem number 1. Okay? Let's go to problem number 2. Let's find the x and y-intercept here. Let me get the x-intercept first. So I'm going to plug in a 0 for y to find the x-intercept. So if I put a 0 in here, I'll have 4x equals 10, because 2 times 0 is nothing. I'll divide by 4, and I'm going to get 2.5. So my x-intercept must have been 2.5. Okay, let me get my y-intercept. I got to plug in 0 for x. Okay, if I put a 0 in here, this is nothing, and I get negative 2y equals 10. So don't forget that negative sign in front. Divide by negative 2, and I'm going to get y equals negative 5. There's my y-intercept. So here would be the x-intercept and y-intercept for problem number 2. Okay? So there would be a couple examples of finding x and y-intercept. We can then use intercepts to graph our equation. They want me to graph 6x plus 7y equals 42. It says label the points where the line crosses the axis. That means find the intercepts, okay? Well, let's do that. Let's get the x-intercept first. The x-intercept would be, we have to plug in a 0 for y. So let's do that. 7 times 0 is nothing. I'd have 6x equals 42. And I can divide by 6, and x would equal 7. So there's my x-intercept, 7, 0. Now let's get the y-intercept. I have to plug in a 0 for x to find the y-intercept. Okay, so let's do that. I'll put a 0 in for x. So 6 times 0 is nothing. I get 7y equals 42. And I can divide by 7, and y must equal 6. Okay, all I need to do is graph this then. So 7, 0, and 0, 6. Let's go to graph paper, and I want to graph 7, 0. There's my x-intercept. And 0, 6, there's my y-intercept. And then I want to take my ruler out and draw a line through these. I'm going to do that as neatly as I can here. Because remember, any point on this line makes this equation true, so you want to be neat with your line as best you can. I'm trying to do that here as best I can. Oops, that's not very good. Let me try that again. There, that looks a little better. Don't forget to put arrows at the end. And there is a graph for the problem that we just set up. 6x plus 7y equals 42. Okay? All right, so let's keep going. Another thing they're going to ask us to do in the homework is they will ask us to use a graph to find intercepts. Like in this example, it says identify the x-intercept and y-intercept of the graph shown at the right. There's no work to do here. This is just knowing vocabulary. So here's my x-intercept. I'm going to highlight it in orange. It's right here where the line crosses the x-axis. Can you see that this point is 1, 2, 3, 4 to the left? So the x-intercept, I'll write it underneath here, is negative 4, 0. Okay, now my y-intercept, again, this is no work. It's just knowing the term. The y-intercept is where my line crosses the y-axis. So that would be right over here, and that would be the point 0, 2. So there's my x-intercept and my y-intercept for that sample. This little key concept box is trying to show me a couple things that are important. Let me cover those up for a minute. Here's the main thing that I try to always teach every year, and my students have a hard time remembering, so I'm going to make it clear on this. Your x-intercept, where the line crosses the x-axis, the x-intercept, the y value has to be 0 on any x-intercept. So if I write an ordered pair down, like 3, 0, as soon as I see y 0, I know that this point has to be, this must be an x-intercept. Anytime I see an ordered pair that has 0 for y, that must be an x-intercept. Okay? Now, likewise, the y-intercept here, the x value must be 0 on any y-intercept. That's always a truth statement. So if you just gave me an ordered pair, like I'm making something up, 0, negative 8, okay? 0, negative 8. This has to be, this must be a y-intercept because my x value is 0. This is on the y-axis. You always want to remember that fact. If you have 0 for y, that has to be an x-intercept. If you have 0 for x, it must be a y-intercept. They will ask you to do some word problems and graph them using intercepts. So let's try this problem. Do you notice this problem here? First of all, this is standard form, which means it's linear, which means it's a straight line graph. Okay, let's use our intercepts to graph this. So they kind of show that over here. Here's the x-intercept. You notice they put a 0 in for y, which means 4x equals 180. The book's a little sloppy in their work. They didn't show that they're dividing by 4, and that's why they're getting x is 45. So let's go ahead and graph that. 45, this is 45 comma 0. So do you notice they went 45 right, 0, put a point. Now, let's get the y-intercept. That would be here. You notice how they put a 0 in for x. So when they do that, this is nothing. They get 6y equals 180, and they divide by 6, and y equals 30. So this means we have the y-intercept at 0, 30. Now, do you notice when they drew this up, they didn't just aimlessly draw a line across the paper. Here's why. Let's look at what this equation is. It's you renting tables to seat 180 people. The tables come in 2 sizes. The small tables seat 4 people. So 4 persons per table. We don't know how many we need. That's why they used X. Large tables seat 6 people. We don't know how many we need, though, so we have 6y. So if I wrote this out in words, the number of small tables plus the number of big tables, and I should have added here seats, the number of small table seats, I should have said, plus the number of big table seats has to equal the total seats. Okay, does that make sense? The small table seats plus the big table seats would equal the total seats. Well, we have 180 total seats. We have 4 seats at every small table, so this would be my small table seats, and 6 seats for every large table. There are my big table seats. Okay. So when we graph this, we don't want to, in this case, we don't want to just aimlessly draw a line across our paper. Here's why. If you draw a line going over here, you're saying you could have x as a negative amount. Does that make sense? Could you have a negative amount of small tables? And I'm pretty sure you're thinking, well, no, that doesn't make any sense. So we don't want to graph past 0. You could have 0 small tables, but we don't want to have a negative amount. This would get me into negative amounts for x, which I'll put a little red marking here. That can't do that. We can't have negative small tables. It's the same thing over here. We do not want to go past the x-intercept, because if we start graphing down here, now y is getting negative, which means we'd have a negative amount of small tables, and that, or big tables I meant to say. That doesn't make any sense either. So we have to keep our graph in the positives for x and y. That's why we're not just drawing a line aimlessly across our paper. We'll start and finish here and here. Okay? And then we can look at that line carefully, and we can see there's a certain number of, there's certain setups we could have, like 0, 30. We could have 0 small tables and 30 large. Or we could have 15 small, 20 large. Can you see how this graph is crossing 15 right, 20 up? Or we could have 30 small, 10 large. Or we could have 45 small and no large. So there would be some combinations of tables we could have. There's another word example here I'm going to let you look through on your own. I'm not going to do it with you. But there's one last thing I want to finish on my video. I want to quickly show you when this technique works great and when it's better to solve for y and use your graphing calculator. So let's do this problem. Now see, on this problem, using intercepts will work great, and here's why. My x-intercept is easy to find. I'll plug in 0 for y. If I plug in a 0 here, I get nothing. 2x equals 20, and divide by 2, and does it make sense that my x-intercept would be at 10, 0? Well, that works out nice. 10, 0, let me graph it. That's going to be over here, okay? My y-intercept works out nice, too. If I put a 0 in for x, I get 5y equals 20. I can divide by 5, and I just found out y is 4. So 0, 4 is my y-intercept. And I can easily draw a line through those points. This is why we learn different techniques. Now let's look at this problem. Let's try using intercepts here. I'll plug in 0 for y first, which makes this nothing, and I get 3x equals 10. Divide by 3, that gives me 3 1/3. So I would have to graph 3 1/3. I got a guess for that sad. I'm going to say 3 1/3 is probably about there. Okay? Now I got to get my y-intercept. Let's plug in 0 for x, and I get 7y equals 10. And divide by 7, well, that gives me 1 3/7. Let me try graphing that. And I tell you what, I'm going to change colors in my pen so it shows up better. I'll do blue instead for this one. There's that. 1 3/7, I'm going to guess is about right here. Okay, let me draw a line through these things. And that's the answer I think I should get if I'm using intercepts. Now, let me quickly solve this for y, and then I'm going to use my calculator, make a table, and see how accurate my line is. So you will see down here I just solved for y, took away 3x, I divided by 7, I broke this into separate fractions. Let's get this into our calculator now. And you can see I've taken my calculator now. I hit the y equals key and I typed in, don't forget the parentheses, 10/7 minus 3/7 x. Let me make a table of those points right now as you're watching. And now I get a lot of these points are screwed up, but there are some nice points to plot. Do you notice on my table I have the point 1, 1? That would be easy to plot, so I'm going to do that in a minute. Let me check if there's any other ones. What about negative 6, 4? So let me plot those, negative 6, 4, and 1, 1. So I'll do that in green, negative 6, 4, and 1, 1. My line is pretty accurate here. Draw that out.
Mackenzie Jones, if you're in the building, would you please come to the main office? Mackenzie Jones to the main office. Thank you.
And in this case, my line was pretty accurate, but here's the problem. If you misplot either of these, and I must have been, I was pretty accurate. If you misplot either, you're going to see a picture where your line is not quite as accurate, and you're going to see it wavering off. So these type of questions, it's better actually to just solve for y and use your calculator because we did not get whole amounts. But for a problem like this, the intercepts work great here. I'm going to stop the video. If you have questions, you can ask in class.